Have you ever imagined a computer so powerful it makes you question reality itself?
Question reality? That's quite a thought.
Well, Google's new Willow Chip is doing just that. It's a
Really?
quantum computer shattering previous records.
What's so groundbreaking about Willow?
It solved a problem in under 5 minutes that would take
Wow.
the fastest supercomputers 10 septillion years to finish.
10 septillion years? That's mind-blowing.
I know, and some scientists think it's tapping into parallel universes to do it.
No way. Parallel universes? Are you serious?
Yeah, it's like computations happening across multiple realities. It sounds like
That's
science
incredible.
fiction, but it's serious physics.
How does that even work?
Well, quantum computers use qubits that can be both 0 and 1 at the same time. Superposition.
So they handle multiple possibilities simultaneously?
Exactly. An entanglement links qubits so changing one affects others instantly.
Got it.
That's the magic of quantum computing.
But how does that involve parallel universes?
According to the many worlds interpretation, every quantum event happens in all possible ways, each in its own universe. So
Fascinating.
computations might be spread across these universes.
That's a mind-bending idea.
It is, but it's one way to explain the immense computational power.
Makes sense. But isn't the Copenhagen interpretation more widely accepted?
Yes, it suggests quantum states collapse to a single outcome upon measurement. No parallel universe is needed.
So the debate continues.
Exactly. But regardless, Willow's achievement is significant.
Absolutely.
It's a huge step forward.
Are there practical applications yet?
Well, skeptics point out that the problem it solved is theoretical without immediate real-world use.
So it's impressive but not exactly useful now?
That's fair, but it's a crucial step toward practical quantum computing.
True. Don't you think they should focus more on solving real-world problems?
I see your point, but foundational breakthroughs are necessary.
Right. I guess you can't build a skyscraper without a solid foundation?
Exactly. Plus, issues like scalability and error correction need to be addressed. Quantum systems are fragile.
Even minor disturbances can cause errors, right?
Yes, but progress is being made in stabilizing them.
That's good. So we're getting closer to practical applications?
Slowly but surely, it's an exciting time.
Indeed. Can't wait to see what the future holds.
Me too, the possibilities are endless. Hey, did you, catch the news about Google's latest quantum computing breakthrough with the Willow Chip? It's, causing quite a stir.
I heard a little bit, but what's so groundbreaking about Willow?
So, it's a 105-qubit quantum processor, and it solved a problem in under 5 minutes that would take the fastest supercomputers 10 septillion years.
Wait, what?
That's a 1 with 25 zeros.
That's insane. What kind of problem was it solving?
It's called a random distribution benchmark. Basically, Willow had to generate outputs based on extremely complex and entangled quantum patterns. Classical computers just can't handle that kind of complexity.
So this is what they mean by quantum supremacy.
Exactly. Quantum supremacy is when a quantum computer outperforms the best classical computers on a specific task. And Willow didn't just outperform them, it left them in the dust.
Didn't Google claim quantum supremacy before?
Yeah, back in 2019 with a 53-qubit chip called Sycamore. They said it solved a problem in 200 seconds that would take classical computers 10,000 years. But IBM challenged that, saying their supercomputers could do it faster.
So what's different this time around?
Well, Willow has more than double the qubits, and each additional qubit doubles the processing power.
Right.
So it's not just a bit better, it's exponentially more powerful.
That's incredible. But how do qubits actually work? I mean, what's the big deal with them?
Okay, so in classical computing, bits are either 0 or 1. But qubits can be both 0 and 1 at the same time, thanks to superposition.
So they're in multiple states simultaneously?
Exactly. And then there's entanglement, where qubits are linked so that the state of one instantly affects the others, no matter how far apart they are.
Wow.
It's like they're connected by an invisible thread.
That's pretty wild. So that's how quantum computers process so much information so quickly?
Yep. They can explore an enormous number of possibilities all at once. It's like having billions of calculators working in parallel.
But here's where I get confused. Some scientists are talking about parallel universes in relation to this. What's that about?
So, there's this idea called the many worlds interpretation.
Right.
It suggests that every possible outcome of a quantum event actually happens in its own separate universe.
Wait, so you're saying that when a qubit is in superposition, it's like existing in multiple universes at once?
Kind of, yeah. And when a quantum computer performs a calculation, it's, leveraging these multiple realities to process information. It's
That's
one way to
mind-blowing.
explain their immense power.
But not everyone buys into that, right?
Exactly. The Copenhagen interpretation, which is more widely accepted, says that quantum states are just probabilities until measured. No need for parallel universes.
So the idea of tapping into parallel universes is still up for debate?
Definitely. It's a fascinating concept, but not experimentally proven. But it's fun to think about.
Absolutely. So back to Willow, what makes its achievement so significant?
Well, besides the sheer computational feat, Willow incorporates cutting-edge error correction techniques.
Oh, nice.
Quantum systems are super sensitive, so this is a big deal.
Yeah, I've heard that qubits can be pretty fragile.
They are. Even tiny environmental changes can cause errors. So improving stability is crucial for practical quantum computing. Willow's advancements are a step in that direction.
But aren't there skeptics who question the practical relevance of this breakthrough?
That's true. Some critics point out that the problem Willow solved doesn't have immediate real-world applications.
I see.
It's like a proof of concept.
So it's impressive, but maybe not immediately useful?
Exactly. Plus, scalability is a major challenge. We might need millions of qubits for practical applications.
Wow.
So there's still a long road ahead.
Makes sense. So while Willow is a big step, it's not the end game.
Right. It's progress, but there's a lot more work to be done.
Yeah.
The future potential, though, is huge.
Like what? What could quantum computers eventually do?
They could revolutionize cryptography, for one.
Oh, yeah?
They might break current encryption methods, but also create new, ultra-secure ones.
That would have massive implications for security.
Definitely. And in fields like drug discovery, they could simulate complex molecules to develop new medications faster.
That's incredible.
It could accelerate medical breakthroughs.
And maybe even tackle big problems like climate modeling?
Exactly. They could process vast amounts of data to improve climate predictions and help us address climate change more effectively. The possibilities are, well, almost endless.
It's exciting to think about, but we have to be realistic about the challenges too.
Absolutely. It's important to acknowledge the hurdles while celebrating the progress. Healthy skepticism drives innovation forward.
Speaking of skepticism, do you think the focus on parallel universes might overshadow the practical aspects?
You know, that's a good point. While the multiverse idea is fascinating, it's still speculative. We shouldn't let it distract from the tangible advancements being made.
Agreed. The real-world applications are what matter most right now.
Exactly. The engineering feats are incredible on their own. We don't need to venture into sci-fi to appreciate them.
So what's next for quantum computing? What are researchers focusing on now?
Scaling up qubit numbers and improving error correction are top priorities.
Right.
There's also exploration of different types of qubits that might be more stable.
It's an evolving field, for sure.
Absolutely. It's like we're at the dawn of a new era in computing. Who knows what breakthroughs are around the corner?
It's inspiring. Maybe in a few years we'll be having quantum computers in our homes.
Who knows? It's possible. For now, it's exciting to watch the developments unfold.
Definitely. Thanks for explaining all this. I feel like I understand it a bit better now.
Anytime. It's complex stuff, but totally fascinating.
Absolutely.
Always happy to chat about it.
Looking forward to seeing where this all goes.
Me too. Until next time, let's keep an eye on the quantum world.
Will do.
It's an exciting journey ahead. Hey, have you heard about Google's latest quantum computing breakthrough with their Willow Chip? It's, absolutely mind-blowing.
Really? What's so special about it?
So, get this. Willow solved a problem in under 5 minutes that would take classical supercomputers 10 septillion years to finish.
No way! Wait, 10 septillion? That's a 1 with how many zeros?
25 zeros!
Wow.
It's like trying to count every grain of sand on Earth millions of times over.
That's incredible, but how did they manage that?
Well, it's all due to qubits and quantum mechanics. Unlike classical bits, qubits can be both 0 and 1 at the same time, thanks to superposition.
Right. And entanglement lets qubits influence each other instantly, no matter the distance, right?
Exactly. So quantum computers can process an enormous number of possibilities all at once.
So Willow has 105 qubits, making it exponentially more powerful?
Yes. Every additional qubit doubles the processing power, so it's a huge leap forward.
That's amazing. But wasn't there some controversy with Google's previous claims about quantum supremacy?
There was. In 2019, they claimed it with a 53-qubit chip, but IBM challenged that, saying a classical computer could perform the task in days.
So is this time different?
It seems so. Willow's achievement is significantly more advanced, but some skeptics still raise valid points.
Like what?
Well, for one, the problem Willow solved is a theoretical benchmark with no immediate real-world application.
So it's like building a super fast car, but only driving it on a test track?
Exactly.
Yeah.
Plus, practical quantum computing requires millions of reliable qubits, and we're not there yet.
I see your point, but isn't any progress valuable?
Absolutely, but we should be cautious about overhyping these achievements.
Fair enough, but what's this about parallel universes?
That's the wild part. Some scientists think that quantum computing might involve computations happening across multiple realities.
Wait, are we talking about the multiverse?
Yes. According to the many worlds interpretation, every quantum event splits into parallel universes, so maybe Willow is tapping into those universes to compute.
That's mind-blowing, but isn't that just one interpretation?
It is. The Copenhagen interpretation is more widely accepted and doesn't involve parallel universes. It suggests quantum states are probabilities that collapse when measured.
So we don't really know which is correct?
Exactly. But the idea that quantum computing could provide evidence for the multiverse is fascinating, don't you think?
Definitely, but we should be careful not to jump to conclusions without solid evidence.
You're right. It's important to stay grounded while exploring these possibilities.
Well, regardless, it's an exciting time for science and technology.
Couldn't agree more. The potential applications are, limitless. Cryptography, drug discovery, climate modeling.
Let's keep an eye on where this goes.
So, get this. Google's just unveiled this new quantum processor called Willow.
Oh, yeah?
And it's blowing people's minds.
Wait, what's so special about it?
Well, it's a 105-qubit quantum computer, and it solved a problem in under 5 minutes that would take the fastest classical supercomputers 10 septillion years.
10 septillion years? That's insane.
I know, right? It's like trying to comprehend the universe's age multiplied several times over, and Willow just breezed through it.
So how does it even do that?
Okay, so quantum computers use qubits instead of bits, and qubits can be both 0 and 1 at the same time due to superposition.
Oh, superposition, that's the thing where particles can exist in multiple states simultaneously, right?
Exactly. And then there's entanglement where qubits are connected so that the state of one instantly influences another, no matter the distance.
That's some sci-fi level stuff.
Totally. And because of these properties, quantum computers can process a massive number of possibilities all at once, which classical computers just can't handle.
So what's this problem that Willow solved?
It's called a random distribution benchmark. Basically, it had to generate outputs based on extremely complex and entangled quantum patterns, something classical computers would take eons to compute.
And Willow did it in under 5 minutes? That's unbelievable.
I know. This achievement is what's called quantum supremacy.
Oh, I've heard of that.
Where a quantum computer outperforms the best classical computers on a specific task.
Didn't Google claim quantum supremacy before?
Yeah, back in 2019 with a 53-qubit chip, but there was some debate about that. IBM challenged their claim, saying a classical computer could solve that problem faster than Google estimated.
But this time with Willow, it's a bigger leap?
Exactly. With 105 qubits, every additional qubit doubles the processing power, so Willow isn't just a bit better, it's exponentially more powerful.
That's wild. But what about error correction? Quantum computers are super sensitive, right?
Yeah, they are. Tiny environmental changes can cause errors, but Willow incorporates cutting-edge error correction techniques, making it more stable and reliable than previous models.
That's a big step toward practical quantum computing, then?
Absolutely. But here's where it gets really mind-blowing. Some scientists think that quantum computers might be tapping into parallel universes.
Wait, like the multiverse theory?
Yeah. It's like when qubits are in superposition, they're existing in multiple universes simultaneously.
Wow.
And computations are happening across these parallel realities.
That's straight out of a sci-fi novel.
Right? David Deutsch, a quantum physicist, proposed this many worlds interpretation where every outcome happens but in its own universe, and quantum computers might be leveraging that.
So Willow's incredible speed could be because it's computing across multiple universes?
That's one hypothesis. It's a way to explain how it processes so many possibilities simultaneously,
Yeah,
though it's still a topic of debate.
but not everyone agrees with that idea, right?
Exactly. The Copenhagen interpretation, which is more widely accepted, suggests that qubits are just probabilities until measured
Right.
no need for parallel universes.
So it's either quantum magic or multiverse mechanics.
Ha! Pretty much. But regardless, Willow's achievement is stirring up the scientific community.
But are there any practical applications yet?
Well, that's where some skepticism comes in. The problem Willow
Oh,
solved is largely theoretical with no immediate real-world use.
so it's like a proof of concept?
Exactly. Physicist Sabine Hossenfelder points out that while it's impressive, it doesn't directly translate to practical applications yet.
Right. And what about scalability? Can we build larger quantum computers?
That's another challenge. We need millions of qubits for truly practical quantum
Mm-hmm.
computing, and maintaining error correction at that scale is a huge hurdle.
So we're not quite there, but we're making progress?
Exactly. Every milestone like this brings us closer. It's incremental, but
Yeah.
significant, and the potential future applications are incredible.
Like what? What could quantum computers eventually do?
Oh, everything from revolutionizing cryptography to accelerating drug discovery, even solving
Wow.
complex climate models.
That's huge.
I know, it's like we're on the cusp of a new technological era, but we
Mm-hmm.
have to manage our expectations and tackle the challenges ahead.
Makes sense. So, do you think we're actually tapping into parallel universes?
Honestly, it's hard to say. It's a fascinating idea, but whether it's multiverse magic or just quantum mechanics as we understand them, the results
Yeah,
are astounding either way.
definitely food for thought.
Absolutely. And as technology advances, maybe we'll get clearer answers about how these quantum
Hopefully.
phenomena truly work.
Well, I'm excited to see where this goes.
Me too. It's an exciting time for science and technology,
Yeah.
and who knows what breakthroughs are just around the corner.
Can't wait to find out.
Wow, did you hear about Google's latest quantum computing breakthrough with their Willow chip? It's
Yeah,
absolutely mind-blowing.
I caught a headline, but what's so special about Willow?
So, it's a 105-qubit quantum processor that just solved a problem in under 5 minutes. A problem that would take the fastest classical supercomputers 10 septillion years.
Wait,
10 septillion years?
that's longer than the universe has existed.
Exactly. It's like, beyond comprehension. Willow tackled a random distribution benchmark, generating outputs based on insanely complex and entangled quantum patterns.
Mm-hmm.
Stuff classical computers just can't handle.
So this is what they call quantum supremacy, right?
Yes, quantum supremacy is when a quantum computer outperforms classical computers on a specific task. Google's first claim was back in 2019, but Willow takes it to a whole new level.
Right.
Because of the extra qubits?
How does adding more qubits make such a huge difference?
Well, each additional qubit doubles the processing power. So with 105 qubits, it's not just a bit better, it's exponentially better. It's like stacking pennies and suddenly having a mountain of gold. That's a massive
Yeah,
leap.
that's incredible. But how do qubits actually work?
So qubits rely on superposition and entanglement. Superposition means a qubit can be both 0 and 1 at the same time. It's like flipping a coin that's both heads and tails until you look. Schrodinger's cat kind of
Yeah,
thing.
right? And entanglement?
Entanglement is when qubits are connected so that changing one affects the others instantly, no matter how far apart they are. Einstein called it spooky action at a distance. That's wild.
Spooky indeed. So, some scientists are bringing up parallel universes in this context. What's that about?
That's where it gets really fascinating. According to the many worlds interpretation by David Deutsch, every quantum event splits into all possible outcomes, each in its own parallel universe. So when Willow computes, it's like it's processing across multiple universes. That's
Whoa.
mind-blowing.
Wait, are you saying Willow is tapping into parallel realities to compute?
Well, that's one interpretation. Imagine infinite willows working together across different realities to solve a problem. But kind
That's
of
nuts.
awesome.
Do all scientists agree with this idea?
Not exactly. Many physicists prefer the Copenhagen interpretation, which says quantum states are just probabilities that collapse into a single outcome when observed. No need for parallel universes. So there's still debate.
Right. So whether it's the multiverse or not, what's the practical significance of Willow's achievement?
Well, it's a huge step in proving quantum computers can outperform classical ones. But some skeptics point out the problem solved is theoretical with no immediate real-world application. I've heard some
Yeah,
scientists aren't fully convinced.
exactly. They're saying, that's cool, but what can it do for us now?
That's fair. Plus, there are challenges with scalability and error correction. Quantum systems are super fragile. Tiny environmental changes can
Right.
cause errors, so not quite ready for the big leagues.
It's like we're at the prototype stage of a new technology.
Exactly. It's like we've built a rocket that reaches the edge of space but can't orbit yet.
Yeah.
A promising start, but more work to do.
So, what's needed to make quantum computers practical?
We need to scale up to millions of qubits and improve error correction. It's a massive engineering challenge. That's a
Wow.
big leap ahead.
Do you think that's achievable?
I believe so. It's tough, but the progress so far is encouraging. It's like climbing Everest. Difficult but possible. One
Yeah.
step at a time.
What kind of applications could quantum computers have when they become practical?
Oh, tons. They could revolutionize cryptography, accelerate drug discovery, optimize complex logistics. The possibilities are endless. So the potential impact is
That's
huge.
amazing. But if it's so promising, why are some people skeptical?
Mainly because we're not there yet. The achievements are significant, but practical, widespread use is still down the road. Some think the hype might be overblown.
Right.
So a bit of caution.
Do you think the multiverse idea might be too, out there for some people?
Definitely. It sounds like science fiction and it's hard to grasp. But even without the multiverse, the math supports what we're seeing. The results
Yeah.
are what's important.
It's exciting to think about the possibilities, though.
Absolutely. Whether or not we're harnessing parallel universes, advancements in quantum computing are pushing boundaries. It's an
Totally.
exciting time in science.
So, what's your take? Are we tapping into the multiverse or just really smart probabilities?
Honestly, I'm on the fence. But either way, the science is fascinating. It's like, whether the magic is real or it's a great illusion, it's still impressive. I can appreciate
Yeah.
that.
Well, we'll just have to keep watching as things develop.
For sure. Who knows what breakthroughs are coming next? Maybe soon we'll have quantum computers solving real-world problems.
Fingers crossed.
That would be incredible.
In the meantime, we can try to wrap our heads around these concepts. Maybe even take a quantum computing course.
Ha! Now that's ambitious. But seriously, staying informed is key.
Absolutely.
Knowledge is power.
This has been a really enlightening conversation.
Definitely. Let's keep an eye on Google's next moves. The future is quantum. Exciting
Couldn't agree
times
more.
ahead.